I'm a save the best for last kind of guy. So in my perfect world, I'd be showing you guys the coolest parts at the end of the video, like the laser cutter. But I want this video to be sort of a start to finish journey of the birth of the new case for my personal rig. So we're gonna go completely in order, all the way through the bending and the cutting until we arrive here. FreshBooks is the super simple invoicing solution that lets you get organized, save time, and get paid faster. Check out the link in the video description to try it for free. All right, so this machine you're looking at right now is a 2.5 kilowatt. Yes, that is 2,500 watts. Carbon dioxide laser worth about $1 million Canadian rupees. It concentrates all of that power on a spot about 7/1000ths of an inch in diameter, giving it an energy density greater than the sun and allowing it to vaporize up to 200 inches per minute of 20 gauge cold rolled steel. As you watch the laser start a new cut, you'll see an initial flash where the plasma goes flying up as the beam hits the top of the metal. Then you'll see sparks on the bottom from the inert assist gas. Protocase actually makes their own on site with a nitrogen generator, blowing it down towards the grate, which holds the metal in place during the cutting process. So the machine you're looking at right now is purely digitally controlled and has been running about 18 hours a day since 2008, with only about 5 days of downtime. The next stage is deburring. For small parts that would otherwise fall through the grate and get lost in the cutter, there's little tabs to hold them in place that need to be manually removed. But all of the parts do actually get deburred anyway, because while in a perfect world, little bits of melted metal would not cling to the finished parts, because the laser has to slow down going into the corners of a cut, power needs to be dropped appropriately or the size of the cut will change. And CO2 lasers don't respond as fast as the machine needs to move, so power control on the corners is imperfect. So for that reason, 2 sets of rotary brushes are used. First, a high abrasion one to eliminate what they call dragon's teeth and slag, with a less aggressive one to round the extremely sharp corners that would otherwise slice up your hands. Fun fact, the 2 sets of brushes that are used oscillate back and forth by at least 1 brush radius. This ensures that every edge is hit equally from all sides and gives the bare metal a uniform finish for applications where it won't be painted. Next is countersinking, where our very small project was run on a drill press with a spring-loaded depth stop device to ensure that all the screws are perfectly flush. But for larger projects, there's actually a CNC router table that does this automatically. Next is the part where we all do the bender. Do the bender. Oh, I fell off my box. Anyway, actually, this is the part where the metal gets bent. Protocase performs their bends on a press brake with a punch and die system that's designed for air bending, where the punch, the ground-hardened steel piece that is made to be accurate to within about a couple thousandths of an inch, pushes the metal down into the die, but leaves an air gap under it. This technique, combined with the accuracy of the controls being used, so the one you're looking at is a CNC-controlled 60-ton press, and extensive computer simulation of metal bending to compensate for spring back and metal's propensity to stretch better than it compresses, allows air bending to be very versatile and accurate without the same operator skill requirement as bottom bending, where the punch bottoms out into the bottom of the die. At the next stage, PEMs, or self-clinching fasteners, if you're one of those people that actually calls things self-adhesive bandage or facial tissue instead of Band-Aid or Kleenex. And these are standoff stands and nuts that are inserted by a press that applies 6 tons of force to permanently fasten them to the metal. Fun fact, the press doesn't apply its force until it's about a fingernail's width from the workpiece to prevent operators from crushing their fingers. When it comes to welding, there is no single way to do it, but Protocase uses gear from an Australian company called Fronius that helps to alleviate some of the issues with using more traditional MIG and TIG welding techniques, like the tendency, for example, of thin sheet metal to get wavy or even melt back from the attempted join, leaving two ugly pieces of metal and a gap in between instead of a joint. It actually bears a lot of similarity to MIG welding, where a spool of wire is being constantly fed towards the join, filling much the same role as solder would in soldering, except that the difference with Fronius's technique is that thanks to digital control of power and the spool feed rate, the filler metal is actually repeatedly heated and applied 20 to 30 times per second rather than constantly. This results in cleaner work, lower power consumption, and less heat being applied to the workpiece. So with this tech, instead of being limited to working with 16 gauge aluminum or higher, you can go all the way down to about the thickness of a pop can. The only drawback is that machines from Fronius cost about 10 times. There's always a gotcha, isn't there? Router milling is used in situations where the design work is too fine to handle the heat of a laser. So the setup you're looking at is a 5 by 10 foot table with a CNC controlled cutter, very similar to a drill bit that can be controlled to within about 1/1000th of an inch. The coolest thing about this doodad is the automatic tool changer, so more of the process is automated even if it has to make a lot of different kinds of cuts. Then, with all the parts bent and cut, it is finally time for painting. Almost. Rookie mistake number one with any paint job is poor preparation. So, the entire project gets cleaned and degreased, etched with a phosphate to roughen the surface for better adhesion, and, in the case of steel, coated with a light touch of zirconium for corrosion resistance. After that, all the little screw threads and anything else that would be damaged or resized out of tolerance by getting gunked up with paint gets plugged. Heat-resistant masking tape is used for any areas that need to stay bare metal, and then the finished parts are hung up on electrically conductive hooks, where the powder coating powder clings to them due to static electricity. Yet another fun fact, the nozzle of the powder coat applicator is charged at 100,000 volts to make the powder really cling to the parts. So you can actually build up multiple layers of material before they're finally rolled into an oven and baked. Which leads us to the final stage, assembly, where the computer drawings are turned into a real-life object that, if all goes according to plan, somewhat corresponds to the original computer drawing. And from first inspection, I'd say this went pretty darn well. I can't wait to put my liquid-cooled system into this truly one-of-a-kind rack mount case. So huge thanks to Protocase for building it for me. It is really amazing what those guys can do with custom metal fabrication. Speaking of amazing, what if there was a desk that could be lower and then higher? Oh, there is, right. Updesk.com, the providers of the desks that we use here in our editing den, benchmarking room, and in my office. They're fantastic because not only do they allow any individual user to get it customized to exactly the right height for their best comfort while they're working, they are also quickly and easily adjustable. So you can go, okay, I want to be sitting right now. Oh, you know what? I'd rather kind of stretch out my back a little bit and work standing up for a little while. No problem. They've got presets, so all you do is hold the button and boom. It goes to exactly the setting that you set with the preset. They've got a variety of different tabletops, everything from corner desks to large straight desks to, well, smaller straight desks. They've got a lot of different surface coverings that they can do, and a little bird told me that if you contact them directly, they can even work on custom sizes of tabletops as well. So check it out over at updesk.com/Linus, linked in the video description if you've been thinking to yourself, gee, I sure would like a standing desk, one that's well built, high quality, and all that good stuff. So thanks for watching, guys. If this video sucked, you know what to do. But if it was awesome, get subscribed, hit that like button, or even consider supporting us directly by using our affiliate code to shop at Amazon, instructions for which are up here, buying a cool shirt like this one, or even with a direct monthly contribution through our community forum, you get a cool little contributor badge. So now that you're done doing all of that stuff, you're probably wondering, what should I watch next? So click that little video in the top right corner to check out our channel's super fun video with a Christmas relay race. Should be pretty good.